Good morning, class. We are looking at practice test number 2 for the trigonometry, module 2, covering from chapters section 6.3 to 7, inverse trigonometric functions and trigonometric equations and identities. Find the exact value of the expression and justify your answer. No calculators. So just to refresh your memory as far as the inverse functions are concerned, when you're dealing with a sine inverse, y equals sine inverse of x, x is sine y, x is between -1 and 1, and y is between negative power 2 and power 2. This is the restriction we gave to domain of sine to make it a one-to-one function. And it's the same thing for tangent. Of course, doesn't include the endpoints. And so when x is between negative power 2 and power 2, sine inverse of sine of x is x. When x is between -1 and 1, sine of sine inverse of x is x. This is the composite function of inverse functions, okay? As far as the tangent is pretty much like sine, the only thing is the endpoints are not included. Very similar to that. Cosine, the same thing. The difference is that the restriction that we put on cosine was from 0 to pi. From 0 to pi. In order to cover the entire range of -1 to 1. Cosecant follows sine, and of course, y can't be 0, and secant follows cosine. Cotangent also follows cosine. As far as the restriction that we put, of course, the endpoints are not included. So having said that, tan inverse of tan of -2 pi over 3, that one is in the third quadrant. In the third quadrant, tangent is positive, and pi over 3 is the reference arc, just the same as tan of pi over 3, which is square root of 3. Therefore, tan inverse of square root of 3 becomes pi over 3. So the restriction that we have here. Secant inverse of square root of 2. We let this be alpha, beta, gamma, x. It's an arc. And by definition of an inverse function, secant alpha becomes square root of 2. We may not be familiar with that, but we know it's cosine, it's the reciprocal of that. So cosine is 1 over square root of 2. And by the way, I believe everybody knows this is the same as square root of 2 over 2. And that gives us pi over 4. Alpha is pi over 4. Cosine inverse of 1/2, again, we set it equal to some angle, some arc. And by definition of an inverse function, cosine theta is 1/2. That's a common arc, giving you pi over 3. Theta is pi over 3. Tan of cosine inverse of square root of 3 over 2. So we are going to work with this as we did here, and we set this equal to alpha, beta, gamma, theta, you name it. In this case, when we set it equal to beta, by definition, cosine of beta becomes square root of 3 over 2. That's a common arc. Beta is pi over 6. That means we are interested in finding tan of a pi over 6, which is square root of 3 over 2 over 3. cosine inverse of 1.2. If you set this equal to theta, that means cosine of theta is 1.2, and it's undefined because 1.2 is larger than 1. As you know, for sinusoidal functions, the range was -1 to 1, which makes it the domain of its inverse. So this is undefined. Find the exact value of cosine of sine inverse of -1/3. This is not a common arc. And I'm going to remind you of a couple of methodologies. We can use the unit circle, we can use the identity. So let's look at both cases. So first and foremost, what is this? Let it be, for example, theta by definition. Therefore, if you let this one be theta, some arc or x, or you name it, this is the cosine of theta that you're looking for. Sine is negative. As you know, the restriction on sine was from -pi/2 to pi/2. In the fourth quadrant, sine is negative. So we are dealing with sine. We are dealing with the fourth quadrant. Sine theta is defined as y over r. So -1/3, r can never be negative, so y must be -1. And x squared plus y squared equals r squared. X squared plus y squared equals r squared. That results in 2 square root of 2. Let me quickly show you. So x squared plus, when we square -1, we get +1. When we square 3, we get 9. So x squared is 8, and x is 2 square root of 2. By the way, there are two answers, positive and negative. And because of the quadrant, it's positive. And of course, cosine is x over r. Cosine is positive in the fourth quadrant. Okay, so x -1, put it into this. And this x value is 2 square root of 2 over 3. That's using the unit circle. If we want to go with the identities, we know sine squared plus cosine squared is 1. Sine squared plus cosine squared is 1. There are other Pythagorean identities, such as 1 plus tan squared equals secant squared, 1 plus cotangent squared, cosecant squared. When you know that, then you should know, for example, that sine is plus minus the square root of 1 minus sine squared, or cosine is plus minus the square root of 1 minus sine squared. And again, as far as the plus minus, we've decided it's in the quadrant. Which quadrant? And in this quadrant, namely quadrant 4, we should know it's positive. So we go with the plus 1 minus sine squared -1/3 squared. This becomes 1 over 9. 1 minus that is 8 over 9. One over 9, 1 minus that, 8 over 9. And when you take a root, 9 comes out as 3, and 8 is 2 square root of 2, because 8 is 4 times 2. So either way is fine. But you should be familiar with both to be on the safe side. Sine of tan inverse of u. We had done this before a couple of different ways. And again, I want to look at it, but slightly a different approach. So we let tan inverse be something, theta, alpha, beta, gamma. By definition, therefore, tan of theta becomes u. We are interested in sine of theta. And again, reminding you of this situation, theta is tan inverse of u, means u equals tan theta, and so forth. So we know that cotangent is 1 over u because of the relationship between cotangent and tangent. We also know the Pythagorean identity, 1 plus cotangent squared is cosecant squared. We replace it. We take a common denominator of u squared, so the left side becomes u squared plus 1 over u squared. And this is cosecant squared. You know the relationship between cosecant and sine is that cosecant is 1 over sine. Therefore, if this is cosecant squared, sine squared must be the reciprocal of that. So let me quickly write this. So we know that cosecant is 1 over sine, or sine is 1 over cosecant. Therefore, the reciprocal of that is sine squared. So sine is the square root of this, plus or minus. And the u at the top comes out. You can leave the 1 plus u squared inside, and you keep it positive because sine and tangent have the same sign because they both go from the fourth quadrant minus pi over 2 to pi over 2. Of course, in the case of a tangent, the endpoints are not included. So that's the reason. Tan of theta is u over 1, the opposite over the adjacent. So if you draw a triangle, the opposite is u and the adjacent is 1. So take a look, we can say this is u, this is 1. So if you don't have a denominator, you give it the denominator 1. So the hypotenuse is missing. The hypotenuse is 1 squared plus u squared under the radical, right? And we know sine of theta is the opposite over the hypotenuse, which makes it u over the square root of 1 plus u squared. We're going to look at more formulas, sum and difference formulas, double angle, half angle, and so forth. So we remember sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Tan of alpha plus beta is tan alpha tan beta plus tan beta over 1 minus tan alpha tan beta. We have developed those formulas. Now, for the double angle, all you have to do, if you change this to alpha, you get sine of alpha plus alpha, gives you sine 2 alpha. Okay. And over here, cosine of alpha plus beta, you change this to alpha, gives you cosine of 2 alpha. Cosine of 2 alpha has 3 different formats. Sine 2 alpha is 2 sine alpha cosine alpha. Cosine 2 alpha is cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared, and you use them accordingly. Tan of 2 alpha is just sine of 2 alpha over the cosine of 2 alpha, and you end up with this format 2 tan alpha over 1 minus tan squared alpha. Or over here, instead of beta, use alpha. From here, you get to here. Now, if you look at these two formulas, okay, so this one gives you sine squared. This one gives you sine squared. Okay, meaning take this one to the left, take this one to the right, and divide by 2. And the green one, okay, and of course, sine squared, now if you cut the alpha in half, you cut the 2 alpha in half. This one gives you this cosine squared of alpha from here. And if you cut it in half, you get that one. As far as tan squared is concerned, is the ratio of sine squared sine squared over cosine squared. And then you change the alpha to alpha over 2, 2 alpha changes to alpha. That's how you arrive at them. And of course, if that is the case, so what is sine of alpha over 2 plus minus the square root of this? So now all of this, you take a root and you come up with the answer. As far as tangent, we've shown that there are 3 different ways of writing them class, very straightforward, okay? So we can move on. We are interested in finding sine of 195 degrees. We want to come up with the exact answer. And using half angle, 2 times that is 390 degrees. Okay, and so 390 divided by 2, okay, and that is a common arc. 390 class means 360 plus 30, so you, in essence, you're looking at 30. So with that being the case, we are going to use sine of alpha over 2. We're going to write this one plus minus. And since 390 is the same as 30, we're going to change this to 30. And where is this? Quadrant 3. Sign is negative, so we keep the one of those signs, we keep the negative sign. You replace the cosine of 30 with square root of 3 over 2. And just under the radical, if you multiply by 2 over 2, the denominator is 4, comes out as 2, and the numerator, this is 2, this is minus square root of 3 under the radical. So this is the exact answer. And don't forget, it's negative. Okay, I hope everybody can see the negative sign. Let me clean up. (15 degrees). Cosine of 15 degrees, as you know, cosine of 15 is the same as cosine of 30 over 2. The reason we use 30 because it's a common arc. And so we are going to use this formula plus minus. And 15 degrees puts us in the first quadrant. We make it positive only. Replace the cosine of 30 with square root of 3 over 2, and plus minus, we just keep the plus sign. And again, if you multiply the top and the bottom by square root of by 2, let me just, okay, so under the radical, you put 2 over 2. When you do that, the bottom becomes 2. The top becomes 2 plus square root of 3 under the radical. So it looks like this. Again, let me clean up this one so it's hard to see it. And again, that's an exact answer, no calculators. By the way, you can calculate it as cosine of 45 minus 30. You can give it a shot. We want to prove the identities. One of them is secant 2 theta is secant squared theta over 2 minus secant squared theta. And it's a good practice to start with the more complicated side. In this case, the more complicated side seems to be the right-hand side. So we are going to write secant squared over 2 minus secant squared theta by changing the secant into 1 over cosine. Everybody, let's change it to 1 over cosine and work on it. Now this, of course, 1 over cosine squared theta, 2 minus 1 over cosine squared theta. This is a complex fraction. And we can multiply the complex fraction by LCD, which means cosine squared. So I'm going to multiply the top as well as the bottom by cosine squared. So what happens is that the numerator just becomes 1. This becomes 2 cosine squared, and this 2 becomes simply minus 1. Now 2 cosine squared theta minus 1 is cosine of 2 theta. So 1 over cosine of 2 theta, which is the same as secant of 2 theta. So this will be replaced by that. So very straightforward. We are going to move on. Sine cubed plus cosine cubed over sine plus cosine equals 1 minus sine cosine. And we start from the more complicated side. There seems to be the left-hand side that is a more complicated side. And what we do, we keep the denominator, and the numerator, we can factor it as follows. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. That's what we used here, everybody. So sine theta is a, cosine theta is b. So this is a minus, and so if I change this to plus sign here, everybody, this changes to plus sign, this changes to minus sign. I hope you remember that. So I'm giving you two identities. So a cubed plus b cubed is a plus b, sine theta plus cosine theta. This is a squared sine squared theta. This becomes negative minus sine theta cosine theta plus b squared plus cosine squared theta. Okay. So clearly, we can drop the common factor of sine theta plus cosine theta from the top and the bottom. Let's write the rest of them, and let's write sine squared and cosine squared next to each other so it becomes clear. This is 1. We want to solve the equation sine 3 theta is 1/2, and theta is between 0 and 2 pi. So that's a common arc. If you assume this is x, sine x is 1/2. From 0 to 2 pi, it's pi over 6 and 5 pi over 6, where x is 3 theta, because remember, sine is positive in the first quadrant and the second quadrant. And this is pi minus the reference arc pi over 6. Therefore, x, or 3 theta, is pi over 6. We have to add 2n pi. And then, okay, so 3 theta is pi over 6. So 3 theta is pi over 6 plus 2n pi, or 2k pi. When we divide by 3, this becomes pi divided by 18. This becomes 2n pi divided by 3. I'm hoping nobody has any problem with that. And on the other hand, when it's 5 pi over 6, we add 2n pi. Again, we divide by 3, theta becomes 5 pi over 18 plus 2n pi divided by 3. And since it is 3 theta, we are going to use n equals 0, 1, 2. By the way, again, even if you go with the next one and you choose 3, when you choose 3 class, okay, this 3 cancels out to this 3, you get 2 pi plus pi over 18, and it shows that it goes beyond one revolution, a complete revolution. So for example, if n is 0, this goes away, you get pi over 8. If I put n equals 1, just as an example, so 0, I don't have to show, but as an example, n equals 1. If I replace n with 1, I get pi over 18 plus 2 pi over 3. Because this denominator is 18, I'm going to multiply this by 6 over 6, 12 pi over 8. And they add up to 13 pi over 18, and the next one is 25 pi over 18. So that's how you get that. So if you choose n to be 2, you get this one. We do the same thing here. Obviously, when n is 0, it's 5 pi over 8. But when it's 1, okay, just like this one is 12 pi over 18. If I choose n equals 1, 12 pi over 18 and 5 pi, 17 pi over 18. And you can figure out the third one when n is 2 as well. So there are 6 answers. 6 answers. Let me just actually put them all in. 1, 2, 3, 4, 5, 6 answers. We want to solve the equation cosine squared minus sine squared plus sine x equal to 0. And we remember Pythagorean identities. And since this involves sine squared and this involves sine, all we have to do change this one. Sine squared plus cosine squared is 1. Therefore, cosine squared is 1 minus sine squared. So this one will change to 1 minus sine squared. Therefore, we have a 1 plus sine x minus 2 sine squared x equal to 0. Since we are going to solve this by factoring, we want to put it in descending order, and we can multiply both sides by a -1 and put it in descending order. We can move it. It doesn't make any difference how you want to approach that. This becomes positive, these two become negative, everybody. And the reason is because we want to factor it. 2 is a prime number. To factor this is very simple. You say you have sine x, you have 2 sine x, because 2 is a prime number. And then all you have to do, deal with -1. One of them is +1, one of them is -1. Which one is which? Even if you make a mistake, it doesn't matter, you change it. What you have to do, you should check your work as follows. This is sine x. This is -2 sine x. Their sum must be minus sine x, and that works. Therefore, either this one is 0 or this one is 0. If this is 0, sine x is -1/2. If this is 0, sine x is +1. Now, again, I want to remind you of the reference arc. If sine x is 1/2, it gives rise to the reference arc of a pi over 6. So we wanted negative. Sine is negative in the third and fourth quadrant. So in the third quadrant, we add this to pi. In the fourth quadrant, we subtract it from 2 pi. Okay, everybody, so I want to make sure we understand. 2 go from here to here, you're going to say pi plus pi over 6. And this one, you're going to say 2 pi minus pi over 6. This is how we dealt with the reference of sine x equals 1x is pi over 2. That's very straightforward, everybody. Cosine of pi over 2 plus x equals minus sine x. We want to prove that, so we start with the left-hand side and we use cosine of alpha plus beta, which is cosine alpha, namely cosine pi over 2, cosine beta, cosine x, minus sine alpha, sine beta, minus sine of pi over 2, sine x, just the sum and differences, in this case, the sum. And everybody knows cosine of pi over 2 is 0, sine of pi over 2 is 1. So this goes to 0. This is the answer, negative sine x. Tan over secant is sine. Well, obviously we start with the left-hand side because that's obviously more complicated. Tangent is sine over cosine. Secant is 1 over cosine. And clearly, if I multiply the top by cosine, I get sine theta. If I multiply the bottom by cosine, I just get 1. And believe it or not, that's the proof. All right, let's look at this example. We want to prove that cosine to the power of 4 minus sine to the power of 4 is cosine of 2 theta. And clearly we start with the left-hand side, which is a more complicated side. And this is a squared minus b squared. So cosine squared plus sine squared times cosine squared minus sine squared. I hope you recognize, you can see that 4 is an even number, and therefore you can go with a squared minus b squared is a plus b times a minus b. You can use that. And so what happens, this is Pythagorean identity 1. So we are left with cosine squared minus sine squared, and that is clearly cosine of 2 theta. And that's the right-hand side, and that's the proof. We want to prove tan x over 1 plus tan squared is sine x. Cosine x, we start with the left-hand side, which is more complicated. So the numerator is tan x. The denominator is 1 plus tan squared, which is from Pythagorean, one of those Pythagorean identities, secant squared x. So it is equal to secant squared x. Now tan, we change it to sine over cosine. Secant, we change it to 1 over cosine. So secant squared is 1 over cosine squared. A complex fraction. If we multiply the top and the bottom by cosine squared x, what happens is the bottom becomes 1 and we are done. But what happens to the top? Cosine goes away, 1 cosine remains. I hope you see it becomes sine x times cosine x over 1. This is 1, everybody. And this is simply sine x cosine x. Believe it or not, it is the proof and you're done. It is the proof and you're done. That's simple. Two sine of pi over 8 cosine of pi over 8. We are going to evaluate that. Well, sine of 2 alpha is 2 sine alpha cosine alpha. So sine of 2 pi, sine of pi over 2 sine of pi over 8 cosine of pi over 8 is sine of 2 times pi over 8, which makes it pi over 4. What is sine of pi over 4? Square root of 2 over 2. Pretty straightforward, everybody. Two sine of 45 cosine of 45, same thing. It's just like what we did here, sine of 2 times 45 degrees, which is 90 degrees. And you know that sine of 90 degrees is 1. Cosine of 7 pi over 12. Cosine of 7 pi over 12. Well, we can write it as cosine of alpha plus beta, 3 pi over 12 and 4 pi over 12. 3 pi over 12 is 3 pi over 12 is pi over 4, and 4 pi over 12 is pi over 3. And both of them are common arcs, and that's really the key. So according to this formula, therefore, you have cosine alpha, cosine of pi over 4, cosine beta, cosine of, instead of 4 pi over 12, write pi over 3, minus sine of pi over 4, sine of pi over 3. Now, all of them are common arcs, so pi over 4, cosine is square root of 2 over 2. This is also square root of 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 2 over 2. So just those common arcs, plug them in, and notice the denominator is 4 here. The denominator is 4 here. So the product of these two is square root of 2. The product of these two is square root of 6. So the numerator has square root of 2 minus square root of 6. And in both cases, we have the same denominator, namely 4, everybody. Cosine of pi over 12, cosine of 5 pi over 12, plus sine of pi over 12, sine of 5 pi over 12. And again, if you go with those formulas, you should recognize this is cosine of alpha minus beta. Okay, so cosine of pi over 12 minus 5 pi over 12, according to this formula, which makes it cosine of negative 4 pi over 12 or negative pi over 3. As you know, cosine is an even function, therefore it's the same as cosine of pi over 3, which makes it 1/2. Cosine of minus x cos cosine of x. It's an even function. Cosine of 105, we can write it as 60 plus 45, just as an example. I mean, you can write it as 210 over 2 and work on that. And with that being the case, is cosine of alpha plus beta, which means cosine alpha, cosine beta, cosine of 60, cosine of 45, minus sine alpha, sine beta. So we are looking at this one. So minus sine 60, sine 45. All of them are common arcs. Cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2. Sine of 60 is square root of 3 over 2. And sine of 45 is square root of 2 over 2. Again, this has the denominator 4. This has the denominator 4. So the result has a fraction bar with the denominator 4. This is 1 times square root of 2, square root of 2. This is square root of 3 times square root of 2 is square root of 6 with a negative sign. So square root of 2 minus square root of 6 over 4. Pretty straightforward, everybody. We want to find the exact answer. Sine of 50 cosine of 10 plus cosine of 50 sine of 10. This is sine of alpha plus beta. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So look at the right side. That's what you have here, which makes it sine of 50 plus 10, which makes it obviously sine of 60, which makes it square root of 3 over 2. What about sine of 165? We can write it as 120 plus 45. By the way, you can write it as 330 divided by 2 and work on it that way. And we use sine of alpha plus beta. So sine of 120 cosine of 45 plus cosine of 120 sine of 45. Now, of course, this is square root of 2, this is square root of 2. Let's look at 120. 120 class, the let's say alpha is, theta is 120 degrees, then the reference arc is 60 degrees. So it's the same as 60 degrees. You just have to figure out positive or negative. Sine of 120 is the same as sine of 60, positive or negative. In the second quadrant, sine is positive, so the same, square root of 3 over 2. Cosine of 120 is the same as cosine of 60, but positive or negative. In the second quadrant, cosine is negative, so negative 1/2. Okay, so this is positive, this is negative. I hope everybody understands. Again, we have to go back to the quadrant. All of them have the same denominator, namely 4, 2 times 2, 2 times 2. So this is square root of 6, this is minus square root of 2. So square root of 6 minus square root of 2. And this is the exact answer, everybody. ln of secant x plus tan x plus ln of secant x minus tan x equal to 0. We want to prove that. And I remind you of logarithmic properties we learned. One of them says ln xy is ln x plus ln y. So we want to go back. We want to go from right to left. So this ln plus that ln, we can say ln of their product. So we are going to start with the left-hand side. And to prove that, we're going to write the left-hand side as the ln of the product. And we're going to work on that. Now, what happens is this is secant squared minus tan squared, as you know. And we know Pythagorean identities, everybody. Sine squared plus cosine squared is 1. 1 plus tan squared is secant squared. 1 plus cotangent squared is cosecant squared. So I want you to pay attention to this one. If I move the tan squared to the other side, I get 1, and everybody knows ln 1 is 0. Sounds good. Let's look at sine of theta plus cosine theta is squared plus sine theta minus cosine theta is squared equals 2. And to prove that, again, we start from the more complicated side. Clearly, it's the left-hand side. And to do so, we are going to use a plus b quantity squared, which is a squared. That means sine squared. Let me quickly remind you of that. A plus b squared is a squared plus 2ab plus b squared. And of course, if it's a minus b squared, this becomes negative. So with that being the case, we have sine squared plus 2 sine theta cosine theta plus cosine squared theta plus sine squared, okay, minus 2 sine theta cosine theta plus cosine squared theta. So that's very straightforward, everybody. I hope everybody is okay with that. Now, these two cancel each other. This is 1, so is the other one. Or you can say 2 times sine squared plus cosine squared, which is 2 times 1, which is 2. So that's a proof, everybody. Solve the equation 2 cosine theta minus square root of 3 equals 0, and theta is between 0 and 2 pi. We move the square root of 3 and we divide by 2. So cosine theta becomes square root of 3 over 2. Between 0 and 2 pi, cosine is square root of 3 over 2 when it's pi over 6. That's the common arc, and that's a reference arc. And cosine is positive in the first quadrant, pi over 6, and in the fourth quadrant, 2 pi minus pi over 6. So this 2 pi minus pi over 6, because this is the reference arc. Okay, everybody. Now, if we wanted to have a general solution, we just add a 2k pi or 2n pi, and I've done both of them. I've written both 2n pi as well as 2k pi. K or n is an integer. If anybody asks for the general solution, that means all coterminal angles, that would be the answer, and that's the terminology, coterminal angles. 2 cosine squared minus cosine theta minus 1. We want to solve this equation between 0 and 2 pi. This is a dot. All right. Again, you can easily factor this out because 2 is a prime number. Otherwise, you can use a quadratic formula. Since 2 is a prime number, you have cosine theta and 2 cosine theta. And since this is -1, you have no choice but to go with 1 and -1. But the way you put it makes a difference, and that's why you must check the middle term. These two give us cosine theta. And these two minus 2 cosine theta. The sum must be the middle term minus cosine theta. So it works. Therefore, there are two equations. 2 cosine theta plus 1 equals 0. Cosine theta minus 1 equal to 0. This results in cosine theta being -1/2. This results in cosine theta being 1. Again, a cosine theta is 1/2. It gives you pi over 3. Let me just again go with the reference arc. So if cosine theta is 1/2. It results in the reference arc of pi over 3. Since it's negative, in the second quadrant, pi minus pi over 3 makes it 2 pi over 3. In the third quadrant, pi plus pi over 3 makes it 4 pi over 3. Cosine theta equals 1 when theta is 0. So those are the answers. We want to find the exact answer. 1 minus cosine squared theta, 1 minus cosine squared 20 minus cosine squared of 70. And we are going to write sine squared of 20 for this, right? These two. Minus cosine squared of 70, and you remember the co-functions. Sine of pi over 2 minus alpha is cosine alpha, cosine of pi over 2 minus alpha is sine alpha, and so forth. We proved a couple of them, right? I hope you remember we proved those two. So cosine of 70 is the sine of 90 minus 70, or sine of 20. And therefore, I can replace this with cosine 70, or I can replace this with sine 70. And both of them are squared. They cancel each other. They give us 0. These are important, okay? Cosine 70, cosine 20 minus sine 70, sine 20. That sounds like cosine of alpha plus beta. Class, clearly that's the cosine of alpha plus beta. I hope you see that, which makes it 70 plus 20. Cosine of 70 plus 20, which makes it cosine of 90, which is 0. Tan of 20 plus tan of 25 over 1 minus tan of 20 times tan of 25. That sounds like a tan of alpha plus beta, which is tan alpha plus tan beta over 1 minus tan alpha tan beta. It's just like that. So it makes a tan of 20 plus 25, which is tan of 45 degrees. And tan of 45 degrees is 1. We want to find sine of cosine inverse of 1/2 and sine inverse of 3/5. In essence, this is like alpha, and this is like beta. If you set this alpha equal to alpha, set this equal to beta, you're looking at sine of alpha plus beta. So that's what you're looking at. So let's set this one equal to alpha. By definition, cosine of alpha is 1/2, and as you know, it's between 0 and pi, because cosine, the restriction was the first and the second quadrant. Now this one, let's say it's beta, and sine of beta is 3 over 5, and the restriction was the fourth and the first quadrant. So we are asking for sine of alpha plus beta, which uses this formula. So sine squared plus cosine squared is 1. So if I have cosine alpha, I can find sine of alpha, which is square root of 1 minus 1/4 under the radical. This I'm using 1 minus sine squared, okay? And then plus minus and under the radical, and we are going with the positive, because from 0 to pi sine is positive. So this makes it 3/4, and it's square root of 3 over 2. Now, cosine beta, we use the same formula. Sine squared plus cosine squared equals 1. So cosine is the square root of 1 minus sine squared under the radical. Okay. And as you know, the first quadrant and the fourth quadrant, cosine is positive. This makes it 16 over 25, or 4 over 5. Now we got everything. We're going to plug in everybody. Sine of alpha, we have it. Cosine of beta, we have it. Plus cosine alpha sine beta. Just plug in. When we do that, as you can see, the denominator is 10 in both cases. The numerator for this one is 4 squared of 3. This one is 3 with a plus sign. And this is the precise answer, no calculators. Okay, class? Precise answer. Okay, very straightforward. So again, this is sine of alpha plus beta. Cosine alpha and sine beta are given. Using this identity, you can find sine of alpha and cosine beta and pay attention to the quadrant and therefore the sign and come up with this using sine of alpha plus beta. We want to establish this identity, and clearly the left-hand side is more complicated. So if we start with the left-hand side, we can write sine theta over cosine theta. And this is the same thing, just write it. Now we take a common denominator. Clearly the common denominator is the product of these two pieces, cosine theta times 1 plus sine theta. What happens to the top? Sine theta times 1 plus sine theta plus cosine theta times cosine theta. So sine theta times 1 is sine theta times sine theta is sine squared. This is plus cosine squared. So again, I'm going to write it at top of it just to make sure you got that. So this is sine theta times 1 plus sine theta. And this one is simply cosine theta times cosine theta. So clearly, sine squared and cosine squared, they add up to 1, right? So what do we have? What do we have in the numerator? We have sine theta plus 1. And sine theta plus 1 and 1 plus sine theta are identical, right? These two are identical, everybody. So the answer is 1 over cosine theta or secant theta. And that's the proof. To prove this, sine 3 theta over sine theta minus cosine 3 theta over cosine theta equals 2. We start with the more complicated side, namely the left-hand side. So what happens? Take a common denominator, sine theta times cosine theta, then sine of 3 theta times cosine theta minus cosine of 3 theta times sine theta. Class, when you take a common denominator, clearly it's sine theta, cosine theta. This one gets multiplied by this one gets multiplied by this one, keep the same sign. Now, sine 3 theta cosine theta minus cosine 3 theta sine theta sounds like sine of alpha minus beta. Sine of alpha minus beta. Sine of alpha is 3 theta minus beta, which is theta. So the numerator is this. What about the bottom? Sine theta cosine theta. We know that 2 sine alpha cosine alpha is sine of 2 alpha. So if you divide both sides by 2, you get half of that. That's why you get half of 2 sine theta cosine theta, right? And so this is half of sine 2 theta, and the top is sine of 2 theta. They cancel each other, obviously. So you get 1 over 1/2 or simply 2. That's the proof, everybody. Again, very straightforward. All right, we are going to move on and we want to establish more identities. 1 minus sine squared over 1 minus cosine theta is cosine of negative cosine of theta. The left-hand side is more complicated. So since the bottom is 1 minus cosine theta here, this doesn't change, this doesn't change. We change the sine squared to 1 minus cosine squared. Because This is 1 minus cosine theta times 1 plus cosine theta. In other words, a squared minus b squared. Class, let me also write that. So I am looking at a squared in essence minus b squared, which is a minus b, a plus b in any order. Okay. And so 1 minus cosine theta cancels out. We have 1 minus the parentheses. So 1 minus cosine theta is simply negative cosine theta, and that's the final answer. We could have a different take on this slightly. I quickly show you. If you take on the left-hand side, let me grab my, on the left-hand side, if you take a common denominator, this becomes 1 minus cosine theta over 1 minus cosine theta. So 1 minus cosine theta minus, now sine squared is 1 minus cosine squared theta, so minus 1 plus cosine squared theta. And so 1 and negative 1 cancel each other. You have these 2. In the numerator, you take the cosine theta out. When you do that, these 2 cancel each other and create a negative sign. So you get minus cosine theta. Again, that would be a different approach class. In case, so in many cases of identities, you have various approaches. Now, this is clearly the left-hand side, sine theta plus cosine theta over sine theta minus cosine theta minus sine theta over cosine theta equals secant theta cosecant theta. Clearly, the left-hand side is the more complicated side. So what do? Normally, when you have fractions, LCD, everybody. Common denominator would be sine theta cosine theta or cosine theta sine theta. Makes no difference. However you want to, write it is just as good. So we multiply these 2. This becomes sine theta cosine theta. This becomes plus cosine squared. Now we multiply these 2 minus sine theta cosine theta minus and minus plus sine squared theta. I'm assuming we are okay with that. I'm going to write it at top so you'll be clear as to what happened here. So this one is cosine theta times sine theta plus cosine theta, and then minus sine theta times cosine theta minus sine theta. So that's what we have, everybody. Okay. Now, these 2 cancel each other. Sine squared and cosine squared in any order, they add up to 1. We can write this as 1 over cosine times 1 over sine. And the reason I put the cosine first, because I wanted to get to secant. That's why I changed them. I put the cosine first. 1 over cosine is secant. 1 over sine is cosecant theta. And that's the proof of the right side. So everybody's okay with that, I hope. Now, this one, we've done it in class already. I want to show you a slightly different method. We established the identity from the more complicated side. Okay, we went from the right-hand side to the left-hand side. Now, I want to, if they say just come up with the answer for sine for theta such that it doesn't have multiples of theta, you start with the left-hand side and you have various formulas to use. So sine of 4 theta, you can say it's sine of 2 times 2 theta. Okay. So imagine this is alpha. What is sine of 2 alpha? 2 sine alpha cosine alpha. So this is 2 sine of 2 theta cosine of 2 theta. Again, let me just imagine this is alpha. Okay. This is a different method. So 2 sine 2 theta cosine 2 theta. Now, what is sine of 2 theta? Sine of 2 theta is 2 sine theta cosine theta. What is cosine of 2 theta? Well, there are different ways of using it. We're going to go with sine, okay? Again, cosine of 2 theta, I can use this one, I can use this one, but I'm going to use this one because this is sine. 1 minus 2 sine squared alpha, I'm going to change it to theta. Okay, everybody? Now what happens? Four sine theta cosine theta times 1 minus 2 sine squared theta. Remember, ultimately, you want to make it look like that, right? The cosine theta, you keep it. 4 sine theta, take it in because you want to make it look like the right-hand side. Keep this cosine out. Take the 4 sine in. Now, if I distribute the 4 sine, I get 4 sine theta, just like that, minus 8 sine cubed, and that's the proof.